This was unexpected. When we're building something and we have an anticipation of the output product, that sometimes we're surprised. And AI has done this for us several times. One interesting, neat surprise is that GPT-4 and large language models can almost perfectly handle unscrambling text. This is essentially a precursor to being able to decode ciphers, which is kind of scary and also kind of exciting. This is something that quantum computers have promised to be able to break cryptography. Asymmetric key pairs in cryptography have a public key that gives a foundation for a quantum computer to be able to crack the code. Using Shor's algorithm, we can factorize security algorithms like a public key and an RSA cryptographic algorithm, and then we can find the ability to essentially decode anything. And that's what a promise of a quantum computer can do once we get big enough and powerful enough systems. Today we don't have that, but maybe AI is inching closer and faster. OpenAI's GPT-4 can unscramble text. We're gonna try it out. I want to see what it looks like firsthand. This is kind of a little scary because we are approaching an AI being able to solve more challenging puzzles. If it can unscramble text like this, what else can it do? All right, we're gonna dive right into an example. We're gonna give it a try. So we're gonna copy this data over here into a GPT-4 and we're gonna see what it does. Is it gonna work? Is it gonna do the trick? It did! It did it! Check this out. It completely unscrambled the text as a recovered sentence. I mean, as a human, we could eventually unscramble this based on, like we see a capital letter here, we can see some patterns. The AI did it in just mere seconds. Large language models can now perform tasks that are day-to-day for humans. These standard, typically repetitive tasks that a human would normally do can now be completely taken care of by an AI. And some things are surprising with its ability to unscramble text. And if it can do that, what else can it do? Given the right instructions, we can have an AI essentially perform any of the common tasks, even identifying information, organizing information. We're just at the beginning. The AI can do so much, and not hardly anyone is leveraging its capabilities yet. What's exciting is that it has so much capability built into it that's evolving faster at a faster pace than we're not able to keep up, essentially. Its capability is outshining and is growing so fast, but we're not actually leveraging that capability in the real world today. We're using just a little bit. We see here large language models have achieved remarkable performance in many tasks, and what's interesting is that the inner workings, we don't know what's going on. We know that it's a bunch of matrices and floating point numbers. I mean, I can pretend to know. I'm like the matrices, and as they are transposed and multiplied on top of each other, are essentially taking data and putting it into a higher dimension. And as we achieve higher and higher dimensions, we can connect more quickly to specific data points. And so it's able to take and combine meaning across all the data and associate data in certain ways that makes it seem like it's super smart because it can do such high dimensional work. Because it's so powerful, we have hit some general limits on our ability to take advantage of adding additional dimensions, because there's a typical diminishing of return. Once you've reached 10 dimensions, that 11th dimension, the 12th dimension, just over so much incrementally improves. So as we make our algorithms smarter and stronger, we need to be able to figure out how to take advantage of higher dimensions. But what's interesting in this approach, they're taking a study here where they present large language models with interesting character level permutations. Essentially, we're scrambling the numbers, scrambling all the letters. Even with scrambled letters, it can make reason out of all that data, and it understands what you mean and what your intentions is. The advancements of AIs today, large language models, are capable of outperforming human task workers. They can do things better than a human can. They can do it faster and more accurately in many scenarios, including a very interesting one here where they can unscramble text. You can even ask a question with scrambled data and it will get the correct answer. And I want to try it out. I'm gonna ask this question here: which professional golfer won the 2023 Masters tournament? And then we hide the answer in a bunch of scrambled letters. Is it gonna work? All right, here we go. We're gonna give it a try. Let's see what it says. Is it gonna work? I don't know. Based on the evidence provided, it seems like John Ram. B. Wait, is that the right answer? Oh, it is. You got it right. This is very satisfying. Interesting because guess what? Not only was it able to perform a human task, a human probably could go about doing this task pretty right? We have to unscramble the text and then we can get the right answer. But the AI did it in seconds. It unscrambled the text and it was able to discern the correct answer. So what does this mean? What does this mean for, I guess, our jobs, right? Things like that. If the AI can do a lot of this work and a whole bunch of tasks and day-to-days are related to text-oriented activities, there's a lot of room for the AI to take the jobs of a lot of scenarios here. Now, here is one of the challenges as we're automating our systems. The output data is also just, a common text. So if we are trying to automate a system, we would want to make sure that this data is formatted. It has to be formatted so that way we can take it to the next phase of whatever our automation workflow looks like. There's a way to do that too. You can ask the AI to accept a instruction set that will allow it to know when to execute code or request for a code function execution. And it will include the data in the format that you need it to be in so that you can continue forward with the automation. So we see that large language models have the ability to do a lot of interesting tasks that we wouldn't normally think that they could do. We tried out to see what they could do in terms of unscrambling text, which they have no problem. They can do it in mere seconds. And I was kind of curious to see which models they tested this out of sort of, the scrambled bench. So if we take a look at their diagrams, we do see here, we have GPT-4, 3.5, Text DaVinci, Falcon 800 billion, and Llama 70 billion. Using the zero shot that we see, the GPT-4 is basically it's near the top. It can go a little bit higher, but not that much higher. Using a few shot approach, which is where we provide examples of encoding, decoding, and we say, here's an example sentence that's scrambled, and here's an unscrambled sentence, and then we give it some examples. It improves it a lot, a little bit extra for GPT-4, but it also helps the other smaller models. And this is interesting. Check this out. Based on how much we scramble the text, right? You can scramble the letters just a little bit here, like maybe a couple letters per word, or you could fully scramble the entire word or the entire sentence. We do see that there is, it becomes increasingly difficult. The more you scramble the words, the more difficult it is, of course. Though we do see, once we hit 100% scramble, so every letter is scrambled, that the models do have a little bit more challenging time making it work. Now I'm super curious to see what else these large language models can do, what other tasks are at their fingertips. Things that that I wouldn't expect. I was expecting quantum computers to be able to solve protein folding and things like that. However, the AI, our advancements there, it seems to be heading a lot more faster in that direction. Things that I thought quantum computers will solve, AI is already doing it.